Hello and welcome back to Pharma-info. It's Vashish. Now, today's topic is yet another, narcotic analgesic, right? For this also we have to do the synthesis and all, right? So better we should write here, synthesis of methadone hydrochloride, right? Methadone is basically, and this is also obtained from the lead compound that is morphine, right? But definitely morphine is not found to be the starting material for this. All I mean to say is it was designed from the lead called morphine, right? Since it's a narcotic analgesic, right? Chalo. So it is also acting centrally, right? But the unwanted or untoward effects are found to be very less as compared to the morphine and all, because it's a synthetic derivative of morphine, right? Chalo. So let's move on to the synthesis of methadone hydrochloride, right? Methadone hydrochloride. So how this can be synthesized and all, let's see. So before that, before the synthesis and all, usual thing that we are doing that is first and foremost, we need to find out the one that we have to make, right? That means the structure we have to deal with, right? Chalo. So methadone. So what kind of structural information that can be extracted from the name itself, right? So methadone is, that means methadone. So we have a metha means methyl, done, D will take di, right? Chalo. So methyl will appear two times. Methadone, on means it ends up with on, right? Means C double bond O should be here, right? So likewise, we got three informations. One is 2-methyl, that means dimethyl, okay, preferentially attached to a nitrogen, that means tertiary nitrogen, and we have a carbon, a ketone or carbonyl group, right? So let us just try to build the structure of this. So this is H3C, then H2C, followed by C double bond O. We have a carbon. To this carbon, we have 2-phenyl ring system, right? Then we have another carbon, we have another carbon, then we have methyl, we have nitrogen, and to this nitrogen, as I said earlier, we have 2-methyl, right? Chalo. Now let me tell you, so now it's clearly visible that we have a chiral center here, right? So we have a chiral center here, and preferentially it is in a minus LIVO form, right? LIVO form that is found to be pharmacologically active, or rather I should say superior. And that is why at the end of the show, at the verge of the completion of the synthesis, definitely you'll find that first of all we have to develop a racemic mixture, and then we'll go for the enantiomeric separation to isolate the minus form, which is found to be biologically active, even that means superior one, right? Chalo. So minus form, that means and LIVO means it is something like this. If we just try to make it stereochemically, right? Okay, this is found to be something like this, right? Right, like this, right? Chalo. But we'll not go after it. So this is for your information that methadone often you can find methadone in the form of minus. This is the minus form that is found to be pharmacologically active, right? Chalo. So as it is a chiral center, definitely it will appear in the form of a pair of enantiomers, right? So that is why I told. Chalo. So and finally, what is left? Dot HCl. Why? Because we are going to do the synthesis of not methadone, rather methadone hydrochloride, right? Chalo. So now this is all about your structure and all. Now let us see how this can be named. First and foremost, we need to find out the parent one, right? So here the parent is found to be the long chain, long hydrocarbon chain with the carbonyl, right? So that means on. So if we start the numbering from here, 1, 2, 3, 4, 5, 6, 7. This is found to be the longest one, right? So we have heptane. And to that heptane, the carbonyl is there, right? So carbonyl here is acting as a parent. So that is why we should not call it as oxo. Instead of oxo, we should call it as on, right? On at which position? Position 3. So likewise, we just write, heptane 3 on, right? Heptane 3 on. Okay. Heptane 3 on. Chalo. So what are the other things that is also there with this? So at position 6, we have dimethyl amino. So likewise, you should write 6 dimethyl amino, right? 6 dimethyl amino. We have 2-phenyl at fourth position. So likewise 4,4-diphenyl, and you have to arrange it on the basis of their alphabetical priority, right? Chalo. So we have a dimethyl amino placed at position 6, right? It is the 6th carbon that is holding dimethyl amino. The 4th carbon is holding what? Diphenyl. It's very simple, right? And finally heptane 3 on hydrochloride, right? So that's all about the IPC naming and all. Now we'll move to the making of this methadone, right? How this can be made and all, right? Chalo. So how this can be made? So in that very process, all we have decided is just to isolate few portions, right? So this is the one that can be isolated. This is the one This is the one that can also be isolated, right? Once we isolate the middle portion, definitely we are left with two more portions, right? This and that, right? Chalo. So now let's see that. So once we got the isolated product, let's deal with the each and every fragments, right? Fragments which born out of the process of this isolation and all. First, let us deal with this, right? Let's see that what kind of shape that can be given to this, right? Because this is found to be a fragment, right? This need to be completed, right? So that we can just use it for the purpose of undergoing a particular reaction, right? Chalo. So this is your C double bond O. Now to that C double bond O, C2H5 is there. We all know that there is a process by which we can convert C triple bond N into C double bond N O. C triple bond N into C double bond O. How this can be converted? We all know the simple mechanism, right? So initially the protonation, right? The protonation leads to what? The iminic one. The iminic will further get converted to amino. The same amino will get further converted to NH3, right? Once the NH3 will leaving behind what? Leaving behind C double bond O. C double bond O, and finally, because this is as it is in this form, right? And finally, you can find the same amino is in the form of NH4 plus. This is the usual thing, okay? This is the usual hydrolysis that we are seeing on a regular basis, what we can say, right? Chalo. So C triple bond N can be converted into C double bond O, and in addition to this, if we just, and this can be accomplished in presence of a Grignard reagent, right? So definitely RMGX is the one. So with this Grignard reagent, we can not only convert the C triple bond N into C double bond O. At the same time, we can also get what? We can also get the alkyl, which is placed here as C2H5, right? So this is the additional benefit that we can get when we are opting RMGX, that is Grignard reagent. Chalo. So that means what should be the shape which you are going to give to this particular fragment? The shape is found to be something like this. So this is what? This is basically diphenyl acetonitrile or ethane nitrile. So assume that there is no phenyl, right? So that means this is CH3. So CH3CN is found to be acetonitrile. So we have replaced both the hydrogen with both the phenyl, with two phenyl, right? Phenyl rings, right? So that is why this is nothing but diphenyl acetonitrile. Now to this diphenyl acetonitrile, all I want to do is, पहले आपको क्या करना होगा? पहले first and foremost, what you need to do is, first you have to react this, you have to finish this portion, right? Later on we'll see what can be done to this. First we'll just add the portion which is left here. That is what? That is dimethyl amino, placed at position 6. We have to go further, right? 7, right? So here we have something like this. What is left? The left is say here we have another C. That means I'm talking about this is C6, and this one is C7. We have this is C5, right? C5. So as usual we have a place C5, CH2, and then halogen. So this should be the other half, right? Which has to be inserted here. Since we have a hydrogen which can be replaced if there is any chloro as a proximal neighbor, right? If it finds any kind of proximal neighbor as a halogen, right? Then this can readily leave, right? Leaving behind, and the connection has been made. So once I'm just going to introduce this dimethyl amino alkyl halide. So this is basically dimethyl amino. If we just start counting or putting the number, this is 1, this is 2, this is 3. Basically this is what? So this is only hydrogen, right? Otherwise valency is not satisfied, right? Chalo. So now this is your dimethyl amino. So 2 dimethyl amino, then alkyl halide, this is propyl chloride, right? So we need to react them all together like this and that, right? This and that. So what will happen? HCl will leaving behind what? This one. This is the one, okay, that is left with us. Then we'll introduce what? Then we'll introduce This is found to be the first intermediate, right? We have got the first intermediate. This is found to be a single bond, right? Now what next? As I said, C triple bond N can be converted into C double bond A. How? Double bond O. How? In presence of alkyl magnesium halide. So here alkyl, all we need to do is we have to make this area as C double bond O, then H5C2. This is the thing that we need to convert. C triple bond N has to be converted into C double bond O, C2H5, right? That means propionyl. How? RMGX. So RMGX is found to be the reagent that need to be introduced here, right? So here R is found to be C2H5. So likewise, let us just straightway take the reagent, actual reagent that we need, that is H5C2MgBr. This is found to be the actual reagent. So what will happen? The C triple bond N will get converted to what? C double bond O, then H5C2. So thus we got what? Thus we got plus minus. Why? Because this is the chiral center. As there is a single chiral center, so chances of getting a pair of enantiomers, right? Chalo, a pair of enantiomer will develop, right? Chalo. So we have got a plus minus. Now you have to treat this with tartaric acid. Tartaric acid. It is the tartaric acid. In presence of tartaric acid, the enantiomeric separation will take place, and finally you can get what? The LIVO form of what? LIVO form of your methadone. And then once we get the LIVO form, then we'll just treat this with HCl and we can get methadone hydrochloride. So this is how the procedure, this is how the synthesis stands rather. Okay. Now let us see that what we got actually. Okay. For the last 10 to 15 minutes we are with this methadone, the making of methadone. What exactly we got actually. Okay. That we'll see in a single picture, right? So hang on for a second, for a moment rather, please. So here we are with the entire scheme, right? So first what we did diphenyl acetonitrile, right? We just reacted this with dimethyl amino propyl chloride, right? Propyl chloride, and then merging took place on removal of HCl. What happened? Merging took place. It is the merging, and it is the merging that leads to the production of what? That led to the production of what? This intermediate, right? To this intermediate, what we did, we just exploited the principle of converting C triple bond N into C double bond O, right? By taking this alkyl magnesium halide, or to be more precise, ethyl magnesium halide. We have this propionyl moiety, okay, has been inserted to the other end, right? That means C triple bond N has been converted to C double bond O in addition to this C2H5, right? Now with that we got, but here one problem that we faced one problem. That means the one that we got, that is of a racemic mixture, but to that racemic mixture we have introduced plus tartaric acid, and it is the tartaric acid that made the enantiomeric separation, and finally it gave us what? Minus methadone. And once we got the minus methadone, then we just add HCl to develop the salt of this methadone, right? And finally we got methadone hydrochloride. Hope you understood the principle or the procedure of this particular making of this methadone, right? So okay, that's all for today's session, right? Stay tuned for the next video to come. Thank you.